Hey everyone, welcome back to Prepwork Steering. Today we're going to be talking about reflection. So, what exactly are reflections? Well, reflections are a form of transformations in geometry where you can reflect or mirror essentially a shape, figure, segment, point, whatever. So let me just draw a little graph here. So you guys have seen this. This is going to be X, and this is going to be Y. And then let's just say we're going to use, a rhombus. So let's draw a rhombus real quick. Label these points A, B, C, D. And let's say we want to mirror it over the x-axis. So we want to go this way. So our x-axis would be called the line of reflection. That's important to keep in mind. And as I use these diagrams, I'm going to essentially try and represent these properties. So we have our rhombus there. And so the points are going to be A up here, C down here, and this is going to be B, and this is going to be D. Now, why is this? Well, when you're reflecting, the points or the orientation is going to change. So that's the first property here. The orientation is changing. And I think a better way of writing this is orientation is not preserved. So that's the first key point that you should know. And if you don't know what orientation is I think I made a mistake here. This is not messed up these points here. This is going to be B and this is going to be D. I apologize for my mistake. But essentially, let's say you were going clockwise here or counterclockwise. So in this first figure, you can see A goes to D, D goes to C, C goes to B, and B goes to A. And over here we have A going to B, B going to C, C to D, and D going to A. So the order of the points is different, which means orientation is not preserved. All right, moving on. So the next key property here is going to be sort of what reflections preserve. So this is very interesting and also super, super important. So I guess we just draw another diagram here. And this time we're going to use a square. And then let's say we want to reflect it over this line right here. So this would be the y equals x. That's this line right here, the black line I just drew. Well, it's not quite on point. It should be like right down the middle. Yep, there we go. And then it would look something like this. Boom. And then let's say we had the points A, B, C, D. And then if we were to reflect this, we would actually follow a certain rule. So let's say these points were x, y, right? If we reflected over the y equals x line, there are different rules. This one would go to the y equals negative x. So in this case, A would be here. Let's see here. So B would be here, C would be here, and D would be here. Now, the reason I know this is because there are a couple key properties. So the first one is not related to sort of the orientation of the points, but the thing I want you to realize is that when you reflect the figure, right? So when we reflected this square right here, did anything change about the shape when we moved it over here? No. See, when you perform a reflection, you're going to preserve the following. You're going to preserve essentially the whole shape. So the whole shape is going to be congruent, and this means that you're going to preserve side lengths, right? And you're also going to preserve angle measures and any other properties of the shape. I'm going to erase this. So how do I know that sort of the orientation of the points, right? Well, obviously you could perform the rules if you had sort of coordinates. So let's say A right here was, -3 and this was 5. So you would just perform and switch the numbers, right? Just plug in the numbers and you can perform that. But another way to know is that each of the corresponding points are going to be equal distant away. The distance is going to be equal distant away from the line of reflection. Our line of reflection here is y equals x, right? So it's this line right here. It's this thing, right? So let me just erase that. So if we were to connect these points, this distance right here, right? B to here, and then B here. I really should have just labeled this like b prime, a prime, etc. But you can see that this distance, so let's just say this was x, and this was y, and then x would equal y. And that would be the same for each of these. So if I didn't know, so let's say I didn't know what a was, right? I can just look over and say, hey, this distance, what would that be? Which one would line up? Well, it would be this one right here. Now, I didn't draw this correctly, but yeah, it's definitely getting quite messy. There's no need to sort of memorize these rules because there are certain properties that you can essentially remember. But the last thing I want to sort of touch on is the line of reflection is the perpendicular bisector of the line that connects the corresponding points. So if I just erase all this and keep this line that we have here, this x and y, this is going to form right angles. And this is going to be useful in the future, maybe if you use proofs, and just generally knowing the properties is going to be super useful. So I was lying. Another thing that I want to do here is just give you a summary of the rules. So let's say we had reflection, and these are just going to be the basic rules. And then this is the rule right here. So if you were to reflect, not in, but reflect over the x-axis, the y-axis, y equals x, and y equals negative x. And now we'll draw this out. So let's say we had a graph here. So this is for y equals x. This is going to be this line. And y equals negative x. I'm going to use a different color this time. It's going to be this line. All right, so what are the rules? Well, I will write the rules out. So this is going to be x, y. All these are going to start at x, y. You're just going to have your starting pre-image. And these are going to be the same. And they're all going to change. To what? Well, it's all going to be different. So this is going to be x equals negative y. This is going to be negative xy. This is going to be y x. And this is going to be negative y, negative x. Well, that does it for reflections, and I hope you guys learned something. And yeah, thank you for watching.